So we'll start with the presentation by UAL on the design guidelines and how we worked on this topic. Then TNO will tell us more about their biorefinery activities and how they made from bio-waste a valuable input material. Then Antje from the DITF will tell us more about the wet and the melt spinning. And then Willem from Centexbel will talk about the fabrics and all the finishing, coating, dyeing which was performed on our bio-based fabrics. And then to end, our two end-use partners, MITWILL and VRETENA, will show their prototypes and explain how these have been developed. So this is translated into the following agenda. So we will have 3 presentations, followed by a Q&A session. So please keep your questions in mind for the Q&A. And then we will finish with the 2 other presentations, followed again by a Q&A session. So first, I would like to give the word to Becky and Laetitia from UAL, who will present our design guidelines. Thank you.
Thank you. Yeah, Laetitia, you can come up. So I'm very quickly just going to say hello. I was the work package leader on work package 1, which was the design strategy. We developed the 10, the Bio 10, and number 1 is designed for collaboration. So true collaboration style. I'm actually handing straight over to Laetitia, and actually to Freya as well from circular.fashion for Lien. So guys, take it away.
Hi everyone, so I'm going to be presenting this set of analog tools that we've been developing in the design work package, which we call the Bio 10, which are design guidelines for bio-based, circular and local fashion and textiles. So these guidelines build on a wealth of knowledge and various tools that exist in various institutions, and in particular they are a sort of like continuation and use the same format as the tried and tested TEDS 10. But what we wanted to do with this set of guidelines is ask what changes when we move to bio-based materials. What do we need to consider when we take circular design thinking and we put it specifically in the space of bio and local? So what we found is that current circular design guidelines tend to not really account for the sort of material properties of bio-based materials. We know that they are a bit different and sometimes a bit strange, that like things like viscose dries differently and wears differently through time. So we wanted to integrate all these sort of like material considerations into the Bio 10. And what we found while developing the Bio 10 is that we really need to forefront systemic approaches when we're working like at the junction of these 3 pillars of local, bio-based and circular. So you'll find that in the cards, and you'll see that they are very holistic, that we bring ideas in such as designing for collaboration, designing for systems, designing for communication, also speaking to a range of design stakeholders in the industry. So the format for these cards is a set of 10 paper cards that each have a key sort of concept at the front of them, and then at the back of it that you'll go into a bit more detail and look at different perspectives inside that specific guideline. And there are also examples that can give designers hints and inspire them to take these ideas on in their work. The Bio 10 take a full life cycle approach, so they're really looking at every stage of a product, from the material extraction to its transformation, and in particular its use. And this idea of inspiration is really important to the way that we use these tools. So in practice, the way that we've rolled them out and tested them is that we would connect the tools to best practice cases. So you can see here 3 examples that help to really visualize and get excited about the way in which these strategies can be implemented in design practice. These tools are not the only, so the Bio 10 are not the only analog tool that we've developed in the Herewear project. We've developed a bit of a suite, and they can all be used together or in or separately, and you'll be able to find all of these tools downloadable on the Herewear Hub, alongside with some facilitation guides that can give some pointers for how you might want to run a workshop in your business, for instance. And so all these tools are sort of conversation starters. They're things that we have used in person in lots of different workshops. So we've used and tested these tools project and the needs of designers. So that's led us to wanting a tool that could also be rolled.
Excited about this. We have the design inspiration tool. So we developed this, also working with UAL, in order to provide a tool that really has these 3 pillars as its guiding compass. So we have circularity, which of course we focus a lot on at Circular Fashion, but we also wanted to incorporate the local aspects, the bio-based aspects into this tool. And of course, in order to do this, we really needed to draw on the wide wealth of knowledge that all the partners have in this. So we obviously built on our own knowledge at Circular Fashion and the active work that we're doing with our other partners in the industry, but also in translating these guidelines, complexity of this topic, and to empower designers to actually design differently and feel like they can do this. So we have created this interactive software in order to support the creation of these products as well. And the way that we did it is we got a lot of information about what sort of questions need to be asked, what sort of information is useful for designers. Also thinking about our target audience, we are visual thinkers, so we also ideally want to have this way of working. So it is a questionnaire format, but it essentially goes through the product development process as much as possible. So looking at what your product purpose is, what are your material, your fibre choices, how is it designed, how is it produced, and ultimately how could it end up being circulated through circular business models, looking at repair, return, resale, all of these things. So essentially you would go through this as a user, you go through 4 different sections as I mentioned, make your selections, and then you come out with a tailored result at the end. So this is supposed to give you some inspiration, hence the name, on sort of how you could take your concept forward. And also just to steer your product development. In addition to this, we also have additional resources. So there are an increasing number of companies that are creating circular collections. So we have some great best practice case studies that we put in here that of course we will also keep an eye on to make sure that this tool is up to date. We also have a glossary in here in order to break down the jargon that we often find. So if the user is not familiar with a word, they can then get this information readily. And then finally, we also have the circular design kit, which we also developed. So there's a range of different visual information kind of sources in here, and the idea is that you would probably use this at the start of the design process, but also potentially you could repeat the process later on when your design concept becomes a little bit clear. And as Laetitia mentioned, this is something that can work alongside the analog tools as well, to really use them as a suite. So you can think of this as a whole range of resources to help your design process. And I think that was, yes, what we have.
And Laetitia, I do want to mention to all that the presentations will be shared and available afterwards to all of the audience.
On the recording still?
Yes. Yes.
Nice. I saw the recorder.
Okay. So then I will give the word to Jaap from TNO, who will tell us more about their biorefinery.
Right is forward. Well, good afternoon, everybody. My name is Jaap W. I work for TNO, in the part that does circular materials in all shapes, fashion, and form. And to latch on to the previous speaker, both my shirt and my jeans were bought at the annual thrift fair, celebrating our king's birthday. It's one of those things where, up to the point you can practice what you preach, or you by example, whichever one you want. Okay. This one is for you. There we go. So, introduction just had. So I'll explain to you what biorefinery is, and then discuss the specific applications for textiles that biorefineries can do many things. And we are, as just stated, we are already part both at selecting biomass for this particular application, as well as taking it apart so that it can be used for textiles. Now, there is an official definition of a biorefinery, defined by the International Energy Association, Bioenergy Task 42, don't ask. It basically says you put biomass in and you get products out. And that is shown here graphically in this prism. Light, as you may know, is a whole bunch of colors, or technically a whole bunch of this color, so you can do things with it. To go back a little history, oil refineries have been around for give or take 100 years. Oil refineries were also local, were tuned to the oil at hand, and represents 50% of the profit. And what can you biorefine? The short answer is just about everything, just not the same way, oil. And what does TNO do? Also all of these. Here, in this particular one, in the residues and the aquatic biomass, but different purposes, different biomass, so forth. Now a short story about seaweed. Seaweed has cellulose in it. And the idea was, and the decision was, let's try to take it out. And for this particular application, it doesn't work. So it was the right decision, a good outcome, just not the design one. And that's also good, because then you won't try it again. Now, about straw. Straw has waxes in it, if you've ever felt it, and a bunch of minerals that are in the way. So you take those out, fractionate it, then you get lignin, which you need to do something with. For instance, produce foams for building insulation. The heavy cellulose, you can convert it into paint, and then you can take the cellulose, clean it all up, and make cellulose pulp and give it to the DITF, which will be what does that look like in the lab? Well, you mix biomass and solvent and water, put it in a very expensive pressure cooker, autoclave, the lignin and the hemicellulose dissolve, you take the pulp out, you take the lignin out, and then you have different products. You can also do that larger. That particular unit is 3 stories high, and then you have non-cellulose address for 2.5. That looks like this. So you have untreated wheat straw, extracted wheat straw, where all the extractives have been taken out, and then you have wheat straw pulp, and then you clean it up. And if you really want to see, you can see it over there, and you can clean it up close and personal, so to say. So, where do we go from here? Well, as the previous speaker said, we have tools, some fashion and some more tools, and to whom are you going to sell the fractions? Then you really need to identify outlets for your order fractions. You need to run the numbers. The most important part is, at the end of this project, we are ready to get started. If you want to know more about it, feel free to call me, and I use my number on here. This is my contact information. This QR code goes straight in your contacts and just put me there, just so you know. And this is after the next speaker, I'll be happy to answer questions.
Thank you very much, Jaap. Tell us more about the biorefinery.
And in work package 3, I worked together with Lien and also Peter from Upcut and Lien from Centexbel. And we worked on the yarn extrusion of bioyarns using polylactide acid, so PLA. The wheat straw was one biosource reprocessed into filament yarns. And what you probably have seen already is these flexi dress, what it is made of. So here you see more or less UV stability, low moisture regain, and low outer retention. The Centexbel has a pilot scale equipment for doing the spinning. They can do fully draw yarns, but also partially oriented yarns, and the typical properties that were obtained for the filaments are close to those of polyester. So our titer we chose in the project was about 2 DTFs per filament. We had a tenacity of the filaments between 30-35 centinewton per tex, and the elongation was quite high with 25%. What we have done during the 3.5 years in this project, we tested also the fabrics for stability, so also sweating tests have been done, which have excellent performance in these testing, so no change of the filament itself also from the fabric side. The washing resistance was quite good. Of course, we also examined higher temperatures, what we were satisfied with using it or washing it at 40 degrees C. As you could also see here in person, but also online, the coloring was investigated, and also with bio-based
materials, how to say, pigments and colors, and was able to dye or make a dope dye actually, which is the most wanted one actually. And yeah, Peter was so kind to do these knitting and weaving trials, and you see also a lot of materials here in person. What of course was not perfect at the beginning, we improved a lot, so like this comfort and the softness property problem, when you touch it, it was a bit more rigid, but by adding another biopolyester source, it was possible to increase this comfort property and woven by Peter. What is special, also saves some money, because these ionic liquids are not so cheap as a solvent, but we use for our spinning only recycled solvent, which is offset process is more than over 100 degrees C needs and is more sustainable than the viscose process, because the viscose process uses a lot of chemical. Was up to 8%, but we could vary quite nicely our properties in terms of technical application, that meaning higher strengths, and more textile application, meaning more elongation in your filament. And what we have developed in Enkendorf is a method also to test these fabrics with mechanical liberation, and that is shown here. You see our filaments after testing, so like kind of washing scenario, and you see that you do not form these fibrils, which is sometimes a problem, of course, when you wear it, when you wash it, your textile, it's not nice that it looks older, you know, than it was just newly barred, and once washed, and then it looks like, okay, I have it 1 year. This is something you do not want, and this was a very nice result. You have soft, shiny, non-fibrillating filaments, what increase your use of your fabric, of course. What was important was also done for the PLA, which I did not mention, but we also use recycled PLA, so to really say, okay, is it a possibility to reuse, to recycle the material. And we use, for instance, this is waste from the spinning, so if you start a spinning, of course you do not wind your filament from the beginning, you first have to have stable conditions. This material was used, but we also used fabrics and respun it. That was done without losing any mechanical property. Same was found for PLA as well. And we also did biodegradability tests and proved that our filaments are biodegradable in marine environment. And as already said, we could directly go into knits and fabrics. The key messages I want to mention in the end is that polyester yarns are a very promising alternative, and you see a lot of popping up already in industrial scale and companies working on that. Also for the wheat straw, we saw a source of good quality filaments in the end. And for the future activities, there's upscaling of the yarn extrusion into industrial scale. This is also for the hypercell technology, but also PLA is spun in industrial scale. And we also want to do further evaluation of the end-of-life options. This was 1 hour all. I think, yeah, we also have our contact data from Lien and me. This project, of course. Thank you.
Okay, don't run too far, Antje, because we still have the Q&A session of the first 3 presentations. So please, I give the floor to the audience for any questions or feedbacks. Don't be shy. Okay.
Maybe on the straw, because I know PLA a little bit from another reality where I work a lot in event centers and cups, and then the good breakthrough was that they make it more and more from what you cannot eat, not the potato, but potato skin.
Specifically grown to feed livestock in the winter. Straw is a residue, and so it's not an animal feed. That's grasses that have been sown.
But it is used in farming.
That's so they shred it for chicken coops and put the cows in the winter in the stables and things along those lines. So it's used as stable lining. After that, it's not the cleanest stuff in the world anymore. It's still straw.
Okay.
Do I want to?
It can be that.
Possibly. That wouldn't want. That's not the one I want to try first. But
I have a question for Antje.
Different spinnerets in our lab, so we can start with monofilament as well. But in this project, we both concentrated on the same titer. So we, for instance, use 60 filaments, we use 64 filaments. But we can also double it to 126, or can go to 250. But we also have a spinneret with 500 holes, because our cellulose filaments are also used for carbon fibers, so we can use it as a precursor, put a flame retardant on, and therefore we use really bigger amount of these filaments. So 1,000 filaments are needed to do the food processing into a carbon fiber. And from the titer, it really depends, because it's a air gap spinning. That means you have a hole, you have a gap between the coagulation bath and your spinneret, and in this part, between 5 to 25 millimeters, you scratch your filament, and by this scratching, you determine how thick you want to have it. You know, you have 0.5 DTEX fibers, so really thin, so microfiber range. But we can also go to really thick ones, 1 to 10 DTEX. But this is not usual in the textile. Between 2 and 3 years, so the regime people wants to have their filaments, and then you come into account between 130 to 180 DTEX as a yarn. This is the region where textile people want to have between 150 to 180 usually per titer, and that we can enter easily. This is
Our future path. And our DTEX is 1300.
1,300, so 1,300.
Yes.
Yeah, this is we also have. So you just can combine these two types. So if you have 500, and we also use this for composite, that we use cellulose matrice, and then we have these all cellulose.
Yeah, I think to add, like, since we work on garment and clothing applications in here, where we focused on the small filaments, the thin ones, because that's typically used in clothing applications, but I think both for PLA and the cellulose one, we can go to different titers, to different thicknesses, depending on the application where you go and what's needed there.
Yeah, this is not really a limit, because this technology is actually in the pilot scale, and the Technikum Laubholz is close also to Stuttgart in Göppingen situated, and they, for instance, they have 4 spinnerets with 1,000 holes, so they can produce 4,000 filaments at the same time in theory. I cannot talk of course what is really happening in the hall, but in principle they start with 1,000 filaments. So then if you have 1 DTEX, you would originally be 1.3 DTEX, you have your 1,300. We can combine 2 strands, or can work directly with a 500 depending on what titer you really is very interested. So, but we all have the machinery in house to work on that if you have interest.
Right.
Test.
Thank you very much.
I know there's also an online question.
Yeah, so we have a question online, which asks, why is pre-extraction needed to produce the wheat straw pulp? And in terms of yarn production, did you test the lyocell process?
The second answer is no. I'm not sure if you did, you certainly didn't.
No, we don't spin lyocell in and will not. No, it's not our spinning line is not made for this. You cannot use a lyocell spinning line and do now ionic liquid spinning. There's no chance. Several people who already say it's not possible to do so.
And maybe Antje then to add on that question, what are the advantages of your process compared to the lyocell? Just to understand the positioning.
Yeah, we say we are an alternative, not a substitution, but for instance in the lyocell process you need stabilizers for the solvent, otherwise you get patients. There we are quite flexible from the quality of the pulp. This is one big disadvantage, and also in the process we do not have any complex agents to stop this fibrillation, because lyocell is often a bed fibrillation problem, and we can use a technique where we can find a technical solution for that. So we really have only water, ionic liquid, and the pulp in our process. We don't have any other chemicals at all.
To answer the first question, straws have varying amounts of waxes in them, so if you take straw, we take them out up front and valorize them. The second thing is, in a next iteration of the biorefinery, if you pre-extract multiple biomasses, you can mix them and process them all at once. So you don't need an enormous amount of wheat straw, you can actually use 2 to 3 different biomasses, pre-extract and combine, and then process them in one plant.
Okay, any other questions? If not, then I think we can continue with the second part of the Herewear results. So I will introduce my colleague, actually, Willem, who will present on the dyeing and the coating activities.
So as introduced by my colleague Lien, I'm Willem Uyttendaele, I work at Centexbel, and I will give a short overview, a brief overview of what we have done within the Herewear project with the different partners on finishing, coating, printing of the different textiles produced within the project. So just like everyone, I'm going to quickly show this kind of scheme we have of the whole cycle of Herewear, and where we are located is actually right in the middle. Once the fabrics are made, what we want to do is dye them, print them, coat them, finish them to give them properties and change the look of the materials. So what does that translate to effectively? Bio-based printing for printing designs on clothes, sustainable dyeing methods, because of course if we work with sustainable fabrics, we would also like our dyes to be sustainable. And then finally some different finishes that we can apply to reduce microfiber release or to make the fabrics water repellent. So the first one I will start artificial leather. And we used this kind of a system in which PVC is applied, which is a PVC powder and a plasticizer to make it flexible. And we applied this for biopolymers, both PLA and PHA. So we combine those with a plasticizer to make them flexible, add some water and processing aids to make sure that we can coat them or print them. And that gives us really a strong foundation to work with and develop these artificial leathers and these printing inks. This innovation actually also won the Textile Innovation Award 2 years ago. So one of the things we can do with it is screen printing. So if you want to screen print, of course, if we have some kind of a white example is yellow. This print can be applied with screen printing, which is quite a common technique in textiles, and can either be applied directly or through transfer on a fabric. We also tested whether the prints are washable, which of course is quite important when it comes to clothing, and we noticed that if you wash them at 30 degrees, that we can wash them 15 times with minimal loss of color. Additionally, because we made them out of PLA and out of natural pigments, these materials are also industrially compostable. Then we come to the artificial leather. What we chose here is to actually use PHA instead of PLA. PHA is also a biopolymer made by bacteria, and the advantage that it has is that it's more flexible than some of the PLAs. So what we can do here is make a PHA coating very similar to how we print or how we produce inks. Make a coating, apply this coating on a fabric, and then give it a certain pattern using what is called a transfer or release paper, which gives it this leather look. And these artificial leathers show quite excellent abrasion resistance, good flexibility and durability, and we're also in the process of patenting this solution. Then one of the other aspects on coating and finishing that we did within the project is dyeing. And there we separated it into two parts. So the first one was dyeing PLA materials, so this biopolyester. And there we noticed that we have two options. Either to ease accessibility, we looked into dispersed dyes. These are the synthetic dyes that are used commonly for polyester. What we noticed is that they are essentially compatible with PLA, so you can just use the same tolerance you use for polyester with a PLA. But you can also use bio-based and biodegradable dyes, like for example alizarin or chlorophyllene, which is a green extract from leaves. This dyeing can be done with two different techniques. The first one is exhaust, which is, I would say, the most common techniques when it comes to dyeing PLA. However, with exhaust we notice that there are some issues with the strength of the fabric after dyeing, and you can use these dyes also with hypercell to obtain different colors. So you can see from the 6 earth colors, also the color fastness there is quite good. Then one of the other finishes we applied is for water repellency. For some applications it's quite nice, for example if it rains, if just the water slides off your clothes instead of absorbing, getting wet. And this is why, together with our partners Finipur and Mirtek, we investigated different methods for sustainable water repellency, and we tested them under different conditions on different materials. And we noticed that if we work with proper combinations of water repellency agent, fabric, treatment conditions, that we can get quite good water repellence and water barrier scores. Examples of water repellents are, for example, the Zeeland R3, the Rucodry, and the OC Aquazil text. One of the examples of this water repellent, and of course of the dyes and the prints, you can also find here in the exhibition. And then finally, to close it off, what we also worked on is microfiber release finishing. The goal of these finishes is to reduce the amount of microfibers that are shed from a fabric during the washing process. And for this we actually obtained 2 different fabrics from our partners, so a polyester reference and a polyester cotton. We applied in this partner. Right? So what we see is that ketosol and also biodegradable PUs actually are quite a nice alternative to release, to decrease the microfiber release. So to conclude and to finish these results about work package 4, I can say that dyeing, printing, coating, finishing is possible using bio-based and sustainable materials on these new PLA and hypercell fabrics, but of course some challenges still remain. The first one is the temperature sensitivity of PLA, so for some industrial processes it's useful to go quite high in temperature, which is not really possible yet with PLA. Also when it comes to bio-based and biodegradable dyes, there really needs to be some more research there, because currently what is available on the market is very limited, so this makes the color choice quite limited too. When it comes to water repellency, we have good results, but it's not really a one-size-fits-all. You really need some experience to know how to combine different agents with different fabrics. And also when it comes to the microfiber release, it's quite interesting results, but we still want the colleagues from the different partners if you have any questions. So yeah, thank you very much.
Thank you very much, Willem. And then I think it's now time to come to actually all the work, and all the work combined in the end resulted in some nice prototypes by our partners MITWILL and VRETENA. You can see them also on the hangers already and probably seen in the exhibition. So we combined everything, the design, the materials, and this has been then resulted in some nice end products. So I'll first give the word to VRETENA and Nona.
Hi everyone, I'm Nona from VRETENA, as already also being said. So we will look into the insights from the Herewear project, focus on the garment prototyping. And in the first part, you will see more about the street style fashion, which is also VRETENA in this case. And then in the second part of the presentation will be focused on the corporate wear, is Saman from MITWILL. So I'll then move directly to the benefits that our, let's say, from street style fashion perspective, we wanted to implement the objectives of the project, which means bio-based materials, local and circular products to create for our brand, but at the same time, it should be also aligned with our style and image of the brand. So what we wanted to achieve again is like moving from work to streets. So it's not like a typical streetwear, it's more like a stylish fashion for us. And then also what you see, we have like 2 scenarios. because we have also like two bio-based materials. So one is the hypocell that Antje presented, and then we have also the PLA perspective. The idea was to be able to use other material than polyester or cotton, because in our collection usually we have organic cotton and biocell, but not like a new innovative bio-based material. So the scenario that we will see later on, how we achieved that, was really the close collaboration with all partners from different perspectives. What really helped us are the design guidelines, the Bio10, and also the garment scenarios that were presented in the first session by Becky, Laetitia, and also Freya from the perspective of what tool can be used for the design inspiration. Also, what was important is to create a common language, because we were really very different partners. We had researchers, and yeah, we have us as a brand, corporate way, so it was really a starting point for us. And the material conversation discussions, for example, or workshops was really a great approach. The early prototyping was a very important phase for us, because this is where we for first time saw the really raw materials, or how potentially the final fabric could look like. And in the early prototyping, what we tested with all partners is the PLA. So you can see actually also an example in the exhibition, and you can see where we started and we will end up at the end with the PLA. From woven perspective, so woven textile, and then also for Saman, from MITWILL, from the knit structure. Okay, then I move to the first scenario. This is the flexi dress. Okay, there is a new material coming on the way, and it will be fantastic. It's coming from straw. That was the message. So once we saw it the first time, what we were really impressed is the color. Maybe it sounds a bit like these designers, they think only about colors, but actually this was actually guiding us. So it was really immediately emotional bonding, because when you see the color, it was guiding us. So we decided it should not be woven. And then what I'm showing here is actually the implementation of the garment scenarios that we used based on the tools developed, what was also presented today. And important also for the scenario was to think from different perspectives. Okay, we are guided by the material, which is very different from if you're guided by a product, but also how we connect the dots from life cycle extension, how we connect the dots from textile construction and finishing. For the textile construction, was a big discussion around the knitting. So how can we have a stability in the fabric, a stable fabric, but at the same time also aesthetics. So we decided finally to have like two different, after of course sampling and testing, to have like interlock and up Milano. And then also what we were really during the design phase was a discussion around to have like a multifunctional product. So that's why the dress is actually also a top and a skirt, and you can wear it in a different way. Also the top can be, back and front. Something also new for us was the testing with the network manufacturing, which means that it's like to create these 3D designs, to test how it will look like. Enterprise is, in this case, clear, because from the beginning, design for recycling was important for us, and the bio-based materials in the project are focused on that for recycling and or biodegradability. So the second scenario is a different approach. So the first scenario was material driven. We said, okay, material first, and then we decide what we do. The second scenario was an existing product, already sustainable, meaning we used organic cotton for our first, let's say, product. We also had tested for recycling, so there were already sustainability aspects in this product. So what we did now in the Herewear project is to replace the organic cotton with a new innovative material, which in this case is the PLA. So for us it was important that the criteria were fixed already up front. So it should be a woven material. It cannot be knitted, it cannot be whatever other structure. We want it woven because it should replace our current product, which is a shirt. So we also removed the interfacing, the buttons. So these are small the interfacing is always a question of if this is really good to use it or not. So if you can remove it, better remove it. So this is what we did from the design perspective, and also got the sleeves, but it's more like aesthetics, because we just wanted to have a data from works to the streets. And then again, we used the tool for the garment scenario, and we were thinking about the business model. What can it be, for example, renting, repairing, and all this. What we, at the beginning, we didn't have for our brand, because usually for this, for the renting and repairing, you need also local aspects. So you need to have either a community where you can contact, or you have your own space, or some kind of local facilities are needed. Here, from that perspective, besides the material, were the aesthetics. So it was really a long journey that we finally got a woven material from PLA that can be also aesthetic, not only like for shoes or for pants. And so you will see it's over here. Of course, there's still some work, but overall, it's really achieved what we imagined, because part of the whole scenario was to reimagine this product with a new bio-based material. And we decided at the end to be satin textiles, a satin woven, because we saw that twill and other plain structure is not really achieving the aesthetics that we would like to have. And we need to also convince our users or interests that it's something really fashionable, because this is part of our also style for the Gardner. Okay, and a very short out is one of the triggers, and the person is sitting here, like concept store and hub, where we have also other brands, small creative brands, everybody who is interested, but should have specific criteria, either local aspects or from the sustainability perspective, maybe the materials or the way how it is done. And then also, of course, VRETENA will be presented. And then as a second idea is really the coffee corner, which is actually very normal in Berlin anyway, but where we are, it's not so normal in Wiesbaden. So there, in this coffee corner, that people can come, can talk, can read different articles or books about fashion and with focus on sustainability or circularity, and also have the opportunity to have workshops, but again, with the community in this region, Hessen or Wiesbaden, Frankfurt, and so on. So we started already product, but upscaling is our next step, how to do this that's on the market. Thank you. Saman? I tried.
Thank you very much, Nona.
So some things my colleague Nona has shared with you are concurrent with what we did, but basically the approach as industrial partner in the Herewear project was complementary to the streetwear fashion approach. It was more the B2B approach to have garments that are driven by efficiency and scalability. So for that we had to cut out with the romanticism. We made quite simple and minimalistic designs. So there was a collection made by us, but not only by us in our microfactory, but also with our partners in Europe. So our area that we focus on is we do different things, but basically we try to read. It was characterized by those polo shirts that you see that are hanging here today. We made about 40 of them. They are very impressive in our opinion. They are improvable, but definitely there are worth to be presented as a result of the project today. And everything is a bit like the VRETENA approach that Nona has presented. Only possible for us as a small industrial partner, at least, with networking. So we work with different partners, we do different things, and without those clusters of communities, we could not do that. So therefore, I will tell you in a second what it means to us. And of course, we have to develop and pass on those results for further research at some point, hopefully. These are some early prototypes that we have done, they have not been developed way further than this state, just an impression to see what things could look like. But then we took it to a collection that we have called Ethico. Basically, this collection is the one that I mentioned before, defined by simplicity and minimalism. We implemented different pillars, but basically it's technology, it's advanced machinery, it's communication with partners, reduction of wastes and input materials, of trims, additional markups to the product, and standardization. This is another example of the prototype that is not here today, I think. No, it's not, but this one has been basically knitted in that shape straight from the knitting machine. So there are possibilities to knit garments into prototyping campaign made from 100% PLA. It was undyed, so no pigments were added to the dyeing batch, or to the extrusion batch. Just showing you how we made more of one garment, like more prototypes of one style, and we were testing it in the office environment at first. And then with the next prototyping run, we were producing more and improved the fabric and added some value by adding also color, but also some other biopolyester components. So it's not 100% PLA anymore, which improved the fabric properties and the comfort, and as well the possibilities of circulating it not only within the consortium but also outside. So we have test runs trying with people that are not in the consortium, and the feedback is quite etc. on the Circularity ID platform. We used different tools also to manage the supply chain and this prototyping project, along with the Sketch solution that is called now Sketch 5.0. I think it's the latest version. Long story short, we were trying to make promising. Right. What we learned from everything is that, or not what we learned, but what we would like to move on with is definitely to make use of the work that TCBL was doing. So this clustering of community work is actually very important for us, at least in local terms and meanings, because we believe in the fragmentation and in the multiplication of microfactories locally, at least for us in the region. So local can mean different things, but to MITWILL it's very related to where we are located, and I think depending on where you're geographically, the local aspect or what is important to a microfactory can be very different. So for us in France, for example, it's culture, it's heritage, it's also the cultivation of, let's say, European fashion, more or less. So it is what France or part of France, and the competitiveness that we have in this location is to make use of that and preserve and conserve this value. Then, of course, we would like to push those boundaries further and get more access to those types of materials to improve them and to present them more often for clients. We are getting already conversion requests, but we forward them to the coordinator because the material is not belonging to us, so we will see what happens with that. So the material is still in process. Then, of course, the etc. But this is also something that is easily transportable. But what we can contribute with is the context of the clients that appreciate to work with a local or European textile supplier. It's most of the time not only trust, but also having less communication boundaries and a better understanding. So if someone is asking for something, we are thinking more or less the same way as our clients do. It makes things just easier and smoother. So if you ask another person from another continent to think on something, there's a black box, and the outcome is very different sometimes. If you have questions, we are here for the rest of the day. And again, you find everything on the Herewear community pages and everywhere else. But I hope this was...
Enthusiasm of our end-use partners really helped to increase or the motivation and also the drive to move forward of the research partner and of the people developing the materials, so thank you for that. And then now we still have time for the Q&A session of the work package 4, so the finishing coating and the end product. So please come.
Commercially available.
Who will answer that?
Yeah, but I'm not the right person.
Dieter maybe? I don't know.
Actually, it's an upscaling process, but I cannot say. I hope in 2 years maybe you can find something in the store. Maybe you do already. Not sure about that, and I cannot say, of course. We are a research institute, but there are people in upscaling the technology already, and maybe also have products already out.
I may add something. Okay, I may add something to the hypercell, because hypercell is not only used and produced for garments, but it is also used for composites. So there are two different, let's say, development lines and also commercialization lines which we are doing in the institute.
Everything what we already have in Herewear, and have a product on the market a bit earlier than the hypercell, because we need also somehow to use this knowledge and excitement now, so that these can be transferred to the next. It doesn't matter if brands or researchers or customers or users, because at the end we will lose the knowledge even if we have it now, if we don't have something on the market. This is the way how the world improves and goes. So that's why this is our next step, immediate step, and then we see with the hypercell when we're there how this will then continue. But the first step is really to implement as soon as possible everything with a bio-based material that we will have.
If no one else has a question. With the garments that you made, Saman and VRETENA, where will they go at the end of their life? What recycling route are they made for?
Yeah, so for the PLA, we are still waiting for the final results, but for sure recycling opportunities are there. And we are just matching now the recyclers, because PLA is already confirmed as recyclability is there. And for the hypercell, there are different opportunities. It could be biodegradability that is currently
Easily redissolved, as we already showed it. But you should not forget, in case you have colors and pigments in, then recycling becomes much more complicated. But there are also companies out who are doing already the cellulose recycling. At the moment, of course, cotton. There was Renewcell, or is Renewcell, I'm not on the current state, but they, for instance, they produce recycled cotton pulp. So, and this you can also do with our material, coming back to lyocell and to viscose. For viscose, it's much more difficult, but because during the processing of the viscose, the degree of polymization, this is chemically now, decreases a lot. And if you want to use this material again, it's not so easy, because viscose start with a high DP, going down in their processing. It's a respun, but I cannot, I think the redissolution or dissolution again in Meru can be a problem, and you should not forget the finishes, of course. But that's in all textile at the moment a problem, and then it comes into money. Often recycled materials are much more expensive than the virgin. And then again, we come into regulations. We come into money, what people can pay and should pay for, well-designed circular clothes. I don't know. It's 3-4 months projects, or B2B. Thank you.
Yes.
Thank you. Well, I think I can speak.
Oh yeah.
Yeah, I have a question for each one of you, I hope. So Willem, you were talking about at the end of the process about the research that you're intending, or your group is intending to do about microfabrics. So if you could talk a little bit about what is that research, what aspects are you interested in about that subject, microfabrics that are left after the garments are used.
Yes. So that was intended as, like, I showed some results when it comes to microfiber release, how we decrease it, because we apply this kind of a finish. But to some extent, the question still is what happens to the finish itself, because if some of the fibers come off, some of the finish comes off too, what is happening there? Of course, here we mostly looked at bio-based, biodegradable finishes, but even when it comes to biodegradable, biodegradation depends on the environment where something ends up. So I think there is still room there to investigate this further and to also see if these microfiber release finishes can be applied on materials outside of, for example, fashion, which was investigated here.
I just want to add that, of course, we investigated the finishes, but we also investigated like how the textile structure as such influences the microfiber release. Like if certain knits or woven fabrics give more release than others. If filament yarns made from continuous filaments, they give less release than a staple fiber yarn. So this is something we also investigated and also have some insights on. And I'm sure that Rijs, our partner here, can tell you much more on this in the exhibition.
Thank you.
I have a question. Yes. I have a question about the recycling, also recyclability, more specific for the alternative leather. So, because usually nowadays when you have the coating, it kind of gets splitted from the textile, right? When it's in the end of life. So, did you look at that? What would be the solution?
Yes, so the only end-of-life solution we looked at for now is biodegradation. And because this artificial leather is made with a PHA, which is biodegradable in a lot of conditions, it should be biodegradable. Of course, in most cases, recycling is much more preferred because you can reuse the material for new things. But this is something we are still working on. Because even the artificial leather, we are still trying to improve it further with the next few details to really get to high-end properties. So we're still working on it, and the same goes for recycling. I know you had some more questions.
Yeah. Sorry. Yeah, for Nona and Saman. So you talk about the approach of zero waste in the design of the dress, and also using the concept of zero waste in the shirt as well. And you talk about leftover. So what happened with that leftover as well?
Based on this level, there are different aspects. So for the hypercell, the zero waste perspective was considered from pattern. So this is what we worked and tested in the early prototyping with our partners from Mavine. They helped us to learn how to do that. So they can tell you even more on that at the exhibition. So basically from dress perspective, so flexi dress, it's a zero waste from pattern perspective, and from knitting, because it was knitted to be like that, so there is no waste. For the day shirt, we focused mostly also on the design and aesthetics. So we said if there are leftovers from the cutting, they will go then to our partners, Mavine in this case, because it's also part of the network manufacturing that was in the value chain. So basically you can agree with social enterprises to give your leftovers to them. In this case, our social enterprise perspective was Nona as a partner in the project, so any leftovers will go to them.
Which is the beginning, I imagine, is how you see that idea stepping over other types of products or other conventional fabrication of other fabrics. You see something that is implementable?
It's not a fabric, it's like a branding, and to us at least it was important to make it not detachable. So we tried to brand our product by printing on it, so no additional care label or trims along its life. Is that an answer to your question?
And do you see that model able to be replicated by others, by other designers, by other brands, so that where does that material come from? Is it like the passport? Or the concept of the passport, the garment?
Well, this would be the back end, but it's a good question. It depends on the substrate you work with, and then you have different inks to apply on the product, and depending on the requirements you have. in my opinion, and that's what I love about textiles, is there are many ways to get what you want, but it depends on the requirements. There's not one answer to a product. Because some people ask, what's the best way to print something or to dye something? It always depends on what you want to do with it. So if you want to do curtains that just hang there, the process can be very different from something that you will wear on your skin or not on your skin as a third layer or whatever. Yes, so it can be applied, but you have to you should connect to someone who knows about chemistry, etc., to print it the right way or apply it the right way. But you can also apply it on a label, on a care label, and add it to it. You can also have an NFC button. You can have RFID codes inside of it.
Now I think it's time for the lunch. It's served here as well in the room, so you can walk around and look at our samples and you have a sandwich. So thank you.